Greetings, this is Mr. Sabaya again, and we're doing another video. We're still in Module 3, Topic 2, Equations, Skills, Practice, and we're in Section 2. Okay, and if you picked the packet last week, then go through your packet. It doesn't say Section 2. Look for this right here, Section 4, Solving One-Step Equations with a Bar Model. Okay. We are going to start, actually, this is the front page, but we're going to start on the second page here, and then we're going to go back to that, okay? Because this is really, it explains the concept of what we're trying to do, okay? Now, it says determine what will balance one rectangle in each. Okay, so yours doesn't have all this scratchy in it, right? And so what we're trying to do is we have a rectangle and a bunch of squares on both sides, and the point is that this is balanced. Okay, this is a scale. This is a picture of a scale, and if one side were heavier, it would tilt down, right? Or the other side was heavier, it would tilt down. But right now it's balanced. They equal. Okay, but they're saying how many squares basically would you have to take off to balance with only one rectangle. Okay, so in other words, if I had one rectangle here, how much would I have to take off? I'd have to take off all these other squares to get one rectangle alone, right? But if I took all these squares off, it would droop down, right? So I have to take the same number of squares off both sides. Okay, and that's the concept. That's all we're trying to say with equations, that they always have to be balanced. So if you do something to one side, you have to do the other. So in this case, I said, well, to get my rectangle alone, and I labeled my rectangle X, I have to take off 1, 2, 3, 4, 5, 6, 7 squares. So I took off 7 squares from the right also. So I have my rectangle alone now, and then I look and see what was left. I had 1, 2, 3, 4, 5, 6, 7, 8 squares left. So I have a rectangle here, I labeled it X, and 8 squares. Those squares are worth 1 unit each, so X equals 8 is the point of this, okay? And that's the concept you want to have in mind when you're talking about equations, okay, and solving for equations. Okay. Here, same thing. All I'm doing is looking at my X, how many squares do I have to cross off? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go over here and I cross off 10. And what do I have left? I have 6. So here, the rectangle equals 6 squares. I labeled rectangle X, so X equals 6. Okay? So you go ahead and do the others. Super easy. There's a bunch of them, but they're all the same. Okay? And in this case, we're basically subtracting, okay, and you're just subtracting to see how you would balance it. Okay, so that's all you have to do for those, all of those. Okay, I'm gonna let you do those. Shouldn't be too hard. Okay, now let's go back and let's look at the front page. Okay, now before we do that, I want to introduce a topic to you if you haven't heard it already. It's called inverse operations. Okay. And the inverse operation is the opposite of the original operation. And we'll talk about that in a second. It undoes the original operation. So here's a list. This is the original operation. This is the inverse operation. It undoes the original operation. Okay, so we have addition, inverse operation, subtraction. The opposite, right? Subtraction, the opposite of subtraction, the inverse operation is addition. Addition undoes subtraction. Multiplication, division. Okay? Division undoes multiplication. And if you start with division, you undo it by multiplying. This is key. Write this down in your notes. In fact, make sure that you're pausing and rewinding this video as needed. Often, even now, pause it and write these notes down, okay? is important. Okay, now to solve an algebraic equation, okay, means to isolate the variable, okay, and we'll talk about that in a second. To find a value for the variable that makes the equation true. Okay, so let's go to our math here. Now, go ahead and cross off. It says create a bar model to solve each addition equation, but I'm going to say use inverse operations to solve each additional equation. Okay, so here's how we do it. We take the equation, okay, and when we say solve, that means isolate the variable. Solving means get x alone. What is x here? What plus 12 equals 18? What value? Now we know in our heads we could say that, well, 12 plus 5, 17, 12 plus 6, 18. So x must be 6. Okay? Remember, a variable is some unknown number, right? So in this case, but instead of doing that in our head, we are just going to we're going to isolate it by using inverse operations. So look, the equation said x plus 12 equals 18. Well, the inverse operation, the opposite of adding 12, is subtracting 12. Now, here's one of the important parts. You have to do it to both sides, because remember the scales we looked at? We want them to be balanced, okay? So you have to do them to both sides. So 12 minus 12 is 0, so that goes away. We bring down the x. 18 minus 12 is 6, okay? Now, we always check our work, okay? And what we're going to do is I rewrote the original problem, x plus 12 equals 18, but then I said x equals 6, so I think I'm going to take the original problem and put 6 in for x, okay? So 6 plus 12, does that equal 18? Does that replace x with 6? Yes, 16 plus 6 plus 12 is 18, equals 18, check. Therefore, x does equal 6, okay? All right, now I'm not going to do every one of these for you, but I want you to pause and look what I did here, okay? I did the exact same thing. Now remember, you're doing all the problems. You're going to do this one on your own. You're going to do this one on your own. You're going to do all the problems, but I'm helping you with a lot of them here. So pause the video and look at my steps here. Okay, I'm subtracting 7 from both sides, isolating x. Okay, so now we're going to go forward to this page. Okay, this one had a fraction in it that made it a little bit kind of weird, so I'll go ahead and walk through it. So we still want to know what is x. We're using inverse operations, okay? So I rewrote the problem. 3/4 equals 1/2 plus x, okay? I got to subtract 1/2 from both sides because I'm trying to get x alone, so I have to get everything else out of there. I have to do it to both sides, okay? So that gives me 3/4 minus 1/2, okay, equals x, because it's zeroed out over here, right? Okay, now I know that I can convert, because I can't subtract until I have common denominators, but I know 2/4 is the same as 1/2, right? So I can go 3 minus 2 is 1/4. Okay, so I think the answer is x equals 1/4, okay, or 1/4 equals x. So I check it. I take the original answer, or excuse me, the original problem, and I put in 3/4 equals 2/4, which is the same as 1/2, right? Okay, that's what we did here, and that's what we're doing here. So 3/4 equals 2/4 plus 1/4. I want to know. I'm asking myself, question mark. So I can add these now because I have common denominators. 2 plus 1 is 3/4. 3/4 equals 3/4. So yes, x equals 1/4. So this was the correct answer, okay? Okay, now you're going to do these. That one's got a decimal in it. Be careful. Okay. And what else do we have? Okay, we're still going to use inverse operations, but now the original, now we're going to have to use multiplication or division as our inverse operations. Remember, a division is the opposite of multiplication, and multiplication is the opposite of division. So for the first one, we had 3x equals 15, okay? So I need to get rid of this 3. I want my x alone, okay? Well, how do I do that? I divide by 3. 3 is division is the opposite of multiplication, and you can see that 3 over 3 is going to give me 1, so I'm going to have 1x left, right? But I have to do it to both sides, and that way I get 1x, and we don't have to write the 1 in front. It's a visible 1. We know it's there if it's not written. And then 15 divided by 3 is 5. I think the answer is x equals 5. But let's check it. Take the original equation, okay, plug in 5 for x. So now I'm asking myself, does 3 times 5 equal 15? Okay. Yeah, well, yeah, 3 times 5 equals 15, x equals 5. So x equals 5 is the correct answer right there, okay? All right, so here's one that we started with division. Now, I want to explain this one to you. By the way, pause and write that. Don't forget to pause on all of these, okay? Pausing. I have to make these videos short because it takes forever to upload long videos, and you don't want to watch a long video anyway, right? So make sure you're pausing them. Okay. Well, this original problem says x divided by 2. X over 2 equals 4, but we want to get this x alone. How do we do that? Well, okay, so there's the original problem. Now I want to rewrite that just so you can see something here. X over 2 is the same as 1/2 times x over 1 equals 4. So if I were to multiply this together, I would get x over 2. But now I'm doing this for a reason. I'm doing this because I want to show you that now if I multiply by 2, I get a 1 here. You see that 2 times 1 would be 2 over 2, okay? And it turns into the invisible 1. That's why up here we always can just get rid of a denominator by multiplying it in the numerator, right? So 2 times x would that's why we can cancel that denominator. But we have to do it to both sides. Notice I'm doing it over here too. So this piece is the same as this, okay? This piece is, and this piece. Now I'm multiplying it by 2 both sides, okay? And that gives me 2 over 2 times x over 1, or I could just write it x equals 8, all right? And so I don't need to write 1 times x. That's what this says. 1x equals 8, okay? And then there I'm checking my work right there, okay? And it does come up to 4. You pause it. Now pause this video. There's the whole problem. Pause it there. Write it out and think about it, okay? And don't forget to do all of the problem. You're doing all the packet, okay? All right. Now, we're running out of time for the video, so I'm going to tell you now to go ahead and pause this. This one turned out to be a long one, so let me go higher on this. I need to go even higher, huh? Okay, there's all the work, okay? I'm dividing through by the 3/4, okay? So, okay, so just follow along. This is division going on here. This 3/4 is multiplying against x here, so I have to divide it, turns it into a 1, and that gives me 3 divided by 3/4, which is the same as 3 times 4 over 3. Remember how we don't divide fractions, we multiply by the inverse of the fraction, okay? That's what's going on here. This is division. I turn it into multiplication by taking the flipped inverse of the denominator here, okay, and multiply it. So that gives me 12 over 3 or 4, and then I checked my work, okay? Pause that one for sure and watch it, because you're going to need to do one over here again with fraction in it, okay? So make sure you pause that and think it through, okay? Good job. Thank you.